Summer 1950, Los Alamos, New Mexico. 4 physicists walking to lunch: Enrico Fermi, Edward Teller, Emil Konopinski, and Herbert York. They'd been chatting about flying saucers and aliens. Then, in the middle of lunch, Fermi suddenly asked a question. Teller recalled, "So where is everybody?" The whole table burst out laughing, because everyone instantly understood what Fermi meant. Aliens. Where are they? The question sounds simple, but 75 years later, we still don't have an answer. This is the Fermi Paradox, and it leads to one of 3 conclusions. We're incredibly rare. We're the first. Or we're walking into a trap. To understand why Fermi's question matters, let's look at the numbers. The Milky Way contains 200 to 400 billion stars. According to data from the Kepler Space Telescope, nearly every star has at least one planet orbiting it. In 2013, NASA announced a stunning discovery: an estimated 40 billion planets with Earth-like size and temperature, warm enough for liquid water, cool enough for life, 40 billion chances, in just one galaxy. But here's what's even stranger. The Milky Way is 13 billion years old. Our Sun, only 4.6 billion. That means there were billions of years before Earth even existed. Billions of years for life to evolve around other stars. Let's calculate with the most conservative assumptions. Only 1% of planets have life. Only 1 in 1,000 develop intelligence. Only 1 in 1,000,000 develop technology. The final number is still thousands of civilizations. And here's the crucial point Fermi realized. If just one civilization develops interstellar travel, they could spread across the entire galaxy in a few tens of millions of years. A few tens of millions sounds like a long time. But compared to the galaxy's 13 billion year age, that's less than 1%. Like 1 second in a day. They've had more than enough time. So if they exist, they should be here by now. But no radio signals, no spacecraft, no traces of megastructures. Since 1960, the SETI project has been listening to the universe non-stop. Over 60 years. Not a sound. Scientists call this the Great Silence. And it raises a far more terrifying question. What happened to all those civilizations? There are 3 ways to explain this silence, and each has profound implications for our fate. First possibility: life is extremely rare. Earth might not just be special, it might be a miraculous exception. Think about the conditions we have: a strong magnetic field blocking cosmic radiation, a large moon stabilizing our axis, Jupiter acting as a giant shield catching asteroids, vast oceans, perfect atmosphere, the right distance from the sun. Each factor matters, and the combination of all of them, possibly incredibly rare. Astrobiologists Dirk Schulze-Markuch and William Barnes studied the history of evolution on Earth. They found that each major leap took billions of years, from non-living matter to the first cell, from simple to complex cells, from single-celled to multicellular. If even one of those steps is extremely difficult, we might be the only lucky ones who made it through. Sounds good, right? We've passed the hardest part. But think deeper. If life really is that rare, we might be the only place with life in the entire galaxy. Out of thousands of billions of planets, only Earth has living things. What does that mean? It means if we destroy ourselves, life might disappear forever. No one left. No second chance. Second possibility: the great filter lies ahead. But there's another possibility, far more frightening. In August 1996, economist Robin Hanson wrote an essay titled "The Great Filter, Are We Almost Past It?" He wrote, "There seems to be some barrier between dead matter and life spreading throughout the universe. The crucial question is, how far along have we come?" The idea is simple but chilling. On the path from non-living matter to an interstellar civilization, there's a step that's almost impossible to pass. A trap that nearly every species falls into. What could that trap be? Maybe the origin of life itself. Maybe the step from simple to complex cells. Maybe the evolution of intelligence. If those steps are behind us, good for us. We've already passed the filter. But what if the filter still lies ahead? That would mean the hardest part hasn't come yet. Every civilization before us died at the next step, and now it's our turn to face it. We invented nuclear weapons in 1945, just 80 years ago. During that time, we've come close to self-destruction multiple times. The Cuban Missile Crisis, false alarms on warning systems, near nuclear accidents, and now we face even more threats. Runaway climate change, pandemics from biological weapons, artificial intelligence beyond our control. Physicist Michael Garrett proposed a disturbing hypothesis. He believes AI might be the filter itself. Civilizations typically underestimate how fast AI develops. They can't prepare in time. And their lifespan? Possibly less than 200 years from inventing nuclear weapons. We've had nuclear bombs since 1945. 80 years have passed. If the hypothesis is correct, we have 120 years left, or less. In 2022, NASA scientists published research on existential threats. They listed nuclear war, global pandemics, runaway AI, climate change, asteroid impacts. Their conclusion? Humanity is at its most critical moment. We need to look inward, modify our behavior, minimize risks. Because if we don't, we'll become one of the silent civilizations. And this is why the Fermi Paradox is truly terrifying. Not because the universe is empty, but because the universe might be full of dead civilizations. They tried, they failed, and now it's our turn. Third possibility, they're hiding, for good reason. But there's a third hypothesis, called the dark forest theory. Imagine the universe as a dark forest at night. Each civilization is a hunter. Who makes noise first? Who reveals their location first? That one might die first. Why? Because out there might be predator civilizations. In 1981, cosmologist Edward Harrison wrote, "An intelligent species that has overcome its self-destructive tendencies might view any other species expanding into the galaxy as a potential threat." The idea is very simple. If you're a civilization that survived for millions of years, what would you do when you detect a new civilization developing space technology? You might eliminate them before they become a threat. So what would a truly intelligent civilization do? Stay silent, listen, observe, never reveal your location. And us? Since 1974, we've been broadcasting the Arecibo message into space. We've sent Voyager carrying maps of Earth's location. We've been transmitting powerful radio signals into space for over a century. If this hypothesis is correct, we're making a dangerous mistake. We're shouting into the darkness. So what do these three possibilities teach us? If life is extremely rare, we're more precious than we ever imagined. We have a responsibility to protect this planet. This might be the only place life has ever existed in the galaxy. If the great filter lies ahead, we're facing the greatest test, a test that most civilizations have failed. In 2016, physicists Adam Frank and Woodruff Sullivan calculated a different question. For Earth to be the only place that's ever had a technological civilization, how low would the probability need to be? For the entire universe? 2.5 times 10 to the negative 24th, a nearly impossible number. For just the Milky Way? 1.7 times 10 to the negative 11th. That's about 1 in 60 billion. What do these numbers really mean? They're saying that other civilizations almost certainly arose before us. So the question is no longer, do they exist? The question is now, why did they disappear? And more importantly, will we follow the same path? If the universe is a dark forest, we need to be more careful with the signals we send into space. Maybe we should listen first, understand first, then decide whether to speak. Every night you look up at the sky, billions of stars shining, tens of billions of planets orbiting around them, and not a sound. 3 possibilities, 3 different futures. Maybe we're incredibly lucky. Life is rarer than we thought. Maybe we're about to take the greatest test. The test most have failed. Or maybe intelligent civilizations have learned to stay silent. And us? We're still shouting into the darkness. Fermi's question remains: where is everybody? And the answer will determine our fate.